Welcome to Click Academic. This is lesson 2 on the series Mathematical Methods. We are still discussing on Rolle's theorem. Example 2. We are given f of x is equal to x to the power of 4 plus 4x squared plus 1 on this closed interval minus 3, 3. We are asked to prove that these functions satisfy the hypothesis of Rolle's theorem. And then we should find that number c that exists between the open interval minus 3, 3. Solution. So to show that whether this function is continuous or not, we are to test the f of a and b, and our a is minus 3 and b is 3. So f of a, which is minus 3, is equal to, anywhere we have x in the given function, we should replace it with minus 3. So minus 3 to the power of 4 plus 4 into minus 3 all squared plus 1. Minus 3 to the power of 4 is equal to 81. Then minus 3 squared, 9. 9 multiplied by 4, 36 plus 1. So 81 plus 36 plus 1 is equal to 118. Then f of b. Our b is positive 3, which is equal to, anywhere we have x from the given function, we should now replace it with positive 3. X to the power of 4, which is now 3 to the power of 4, plus 4 into x squared, and our x here is 3 to the power of 2 plus 1. This is equal to 3 to the power of 4, 81. 3 squared, 9. 9 multiplied by 4, 36. Plus 1, which is equal to 118. Therefore, f of b is equal to f of a. F of a is equal to 118, and f of b is equal to 118. So now, since the function, the f of a and f of b, they are not divided by 0, so the function is continuous. So now, to see whether the function is differentiable or not, we should differentiate the function. So first derivative of the function is f prime of x, which is equal to derivative of x to the power of 4x cubed. Then derivative of 4x squared, 8x. Derivative of 1 is constant, so it's 0. Then the function now is differentiable, because we differentiate the function and we still have a variable in the function. So since the function is continuous on that interval and the function is differentiable, therefore the function satisfies the hypothesis of Rolle's theorem. Then to find that number c, as I said, we should use the conclusion of the theorem. The conclusion of the theorem says that f prime of c is equal to 0. But from the beginning of the question to this point, we don't have f prime of c. Therefore, how can we find f prime of c? Since we have f prime of x, so anywhere we have x here, we should now replace it with c. Therefore, our f prime of c now is equal to, from the right hand side, anywhere we have x, we should now replace c there. So 4x, and as I say, we should replace it with c. So c cubed plus 8c. F prime of c is equal to 4c cubed plus 8c. But remember, f prime of c is equal to 0 according to the conclusion of the theorem. So this implies 4c cubed plus 8c is equal to 0. To find the value of c now, this is a polynomial function. So don't try to take this 8 to the other side, then divide both sides by whatever. No, because since the highest degree now is 3, you must get 3 values for the unknown. Therefore, the best way is to factorize. So now we should look for the common factor between this term and this term. 4 is common. Then c is here, c is here. There again, c is common. Then open the bracket. To get the term in the bracket, we should divide previous term by the common factor. So 4c cubed divided by 4c is c squared. Then plus 8c divided by 4c plus 2 is equal to 0. This multiplied by this is equal to 0. This implies either this is equal to 0 or this is equal to 0. So therefore, 4c is equal to 0 or c squared plus 2 is equal to 0. We are looking for c, so we should now divide both sides by 4 here. So c is equal to 0 divided by 4, or plus 2 and 0 are like terms, so collecting the like term, c squared is equal to plus 2 across equal sign minus 2. So c is equal to 0 divided by 2, 0. Or since we are looking for c, not c square, we should now take square to the other side. So square across equal sign becomes square root. C is equal to plus or minus square root of minus 2, because once you have square root, it's either plus or minus. Therefore, our c is equal to 0, or this plus or minus telling you that the values are 2, not 1. So either plus square root of minus 2 or minus square root of minus 2. Therefore, OC is equal to positive of square root of minus 2 or negative of square root of minus 2. We have 3 values for C now, but if you look at the interval, from the interval is minus 3, 3. Minus 3, 3 is real numbers. But if you look at square root of minus 3 is imaginary number. Square root of minus 2 is imaginary number. Therefore, our C now is equal to 0, not this negative square root of negative 2. So therefore, our C is equal to 0. Therefore, C is equal to 0. That's all.